Good morning, one and all. Welcome to the Android app development. In this video, we will going to learn Android architecture or Android software stack. So students, let's start to our Android architecture or Android software stack in detail. Android architecture or software stack is categorized into 5 different parts. So first part is Linux kernel. From bottom to top, Linux kernel is at the bottom. Then native libraries or middleware, it is called as. Third part or third type of an Android architecture or Android software stack is an Android runtime. Next is a application framework, that is fourth part, and last part of the Android software stack is applications. So students, let's move to the diagram of the Android architecture. So here we will see that at the bottom there is a Linux kernel. In the Linux kernel there are different drivers, device drivers, that is the software part, that is display drivers, camera drivers, flash memory drivers, audio drivers, Wi-Fi drivers, keyboard drivers, power management drivers. All different types of drivers are in the first part of Android software stack in the Linux kernel. Next part is called as a libraries. In the libraries there are different types of libraries which is developed in C and C++ language. We will see in details all these 5 parts. So there are OpenGL, FreeType, WebKit, SQLite, SSL, Media Framework, Surface Manager, and much more libraries are present in the second part of Android architecture. Great. So what is next? Next is the Android runtime. This is one part of the Android architecture which is at the second level of this stack. So Android runtime mainly consists of Dalvik virtual machine and core libraries. Okay. So application framework is the fourth part of Android architecture. In this application framework, it contains activity manager, window manager, resource manager, content provider, location manager, view system, notification manager, telephony, package manager, and much more. Okay, we will see this all in details in the next part. So, and last is top. At the top of Android architecture there is a application layer or part. In this application layer different apps are there: home, contacts, phone, browser, and so on. Great. So this is all about the architectural diagram of Android or software stack. Let's move to the first part in detail. So what is the first part? At the bottom there is a Linux kernel. So Linux kernel is the heart of the Android architecture that exists at the root of the Android architecture. That contains all essential hardware drivers like camera, keypad, display, etc. All these are drivers required for connectivity between hardware devices and respective app. So these all types of drivers are present in the Linux kernel part. Great. Hope you understand what is Linux kernel and what it contains. So Linux kernel is responsible for power management, memory management, device management, and resource access. So this is the responsibility of kernel, Linux kernel, which is at the root or bottom of the Android architecture. Great. So power management, memory management, device management, all these are required some drivers, and respective drivers are present in the Linux kernel. Okay. Android runtimes relies on Linux kernel for core system services like memory management, power management, process management, threading, security, and much more. So Android runtime, that is the next type or the level in the Android architecture, mainly relies on the Linux kernel. So what is the second type of Android architecture? That is called as native libraries. What these libraries are? So on the top of the Linux kernel, there are native libraries such as WebKit, OpenGL, FreeType, SQLite, Media, C Runtime library, that is libc, and much more. Great. These are all native libraries present in the second layer of Android architecture. So, what is WebKit library? Is responsible for browser support, SQLite for database, FreeType for font support, Media for playing and recording audio and video formats. What is OpenGL? OpenGL, that is Open Graphics Library, and SGL, that is Scalable Graphics Library. And both these types of libraries are related to graphics. So these are graphics libraries for 3D and 2D rendering respectively. Then native libraries are developed using C++ languages and used by components of Android system. Okay, hope you understand what is meant by native library. If you have any problems or queries regarding native libraries, let me know in chat window or comment box. Hope you enjoying watching these videos. Great. So this is the second layer in Android architecture. Next is, that is third type of Android architecture, is Android runtime. It is also called as ART, Android runtime. So Android runtime is the third section or the part of the architecture and available on the second layer itself, that is native libraries. At that layer itself there is a Android runtime. Okay, so in this section or type provides a key component called Dalvik virtual machine. Okay, that is DVM, which is a kind of Java virtual machine specifically designed and optimized for on Android. Great. We all know we can write our code in Java itself in Android for developing our apps. So whenever there is a Java language, that means Java virtual machine is required to run or execute the Java's code. But instead of that, it is similar to Java virtual machine, that is called as Dalvik virtual machine. It is mainly designed for Android for optimized performance of the Android apps. Okay, so in Android runtime there are core libraries and Dalvik virtual machine, which is responsible to run Android applications. Great. We know in JVM, Java virtual machine, when we write our code in Java, first translator is required, that is called as compiler, and second language translator is required, that is called as interpreter or just-in-time compiler, JIT compiler. So in Java, to translate into its native machine language, for example, for Windows native language is there, for Mac OS native language, or Linux native language is there. So converting our Java code into respective machines native language, what we required? We required JVM installed and that particular machine. Great. There are, for Java, translate the code, there are two different translators are required. One is the compiler and second one is the interpreter. Okay. So Java, we know it is a platform independent language. That means we can run our code on any platform. Okay. So we know all these concepts in the Java language. So what is JVM? JVM is similar to DVM, that is the Dalvik virtual machine is like JVM, but it is optimized for mobile devices. Okay. It consumes less memory and provides fast performance. Android runtimes uses DEX files, which is a type of bytecode. We know in Java also, when we first compile the Java language, then it converts into bytecode. Okay, so next, specially designed for Android only. Android runtime, the extensions of the file, that is the DEX files, called as a DEX files, which is a type of bytecode and specially designed for Android only, which helps ART, that means Android runtime, to manage memory more efficiently. That is the main part, because in Android response time we want more. That is whenever we click on any buttons or views, directly we can open different forms views immediately. Okay, that means response time is very fast. That for that purpose in Android runtime we have to use DVM, that is Dalvik virtual machine, instead of JVM, but it is similar to JVM. Great, because to manage memory faster and more efficiently. ART also has a very efficient garbage collection. We know what is garbage collection. That means memory management, that is static memory management. There are two types of memory management. One is static memory management, another one is dynamic memory management. Okay, but from Java it is only dynamic memory management. We know in C language, whenever we manage the memory dynamically using different functions, malloc, calloc, then whenever we manage the memory which is stored on the heap partition, and when we can delete the memory, we can use free function manually. If we don't release the memory using this function in C language or in CPP also, then what happens, guys? That memory does not get released and it creates memory leakage problems. That's why that problem is crucial, because due to this memory leakage problem, memory get wasted. We cannot use that memory. Okay, that purpose we have to restart our machine, then only that reserved memory get released in C++ languages. But in Java, to overcome that type of disadvantage, memory leakage, what there is a garbage collector concept is arise. In garbage collector, it is its responsibility, that is GC function is there, so that clears the memory which is reserved dynamically. So it is not the responsibility of the programmer like in C++. Here also in Android runtime, very efficient garbage collection is there. So it releases the memory efficiently whenever the object or its reference is get dead or deleted dead, then automatically that garbage collector removes these references or objects from the memory itself. So it is a most important concept, and it is also in the Android runtime, and it is very efficiently handled by the garbage collector. Guys, hope you understand what is meant by ART, that is Android runtime. This is the third type of Android architecture. Great. So let's move to the next part, that is fourth part, that is called as Android or application framework. On the top of the native libraries and Android runtime, there is a Android application or framework. Great. So application framework layer provides many higher level services to applications in the form of Java classes. Application developers are allowed to make use of these services in their applications. Android framework includes Android's APIs, which is written in Java itself. Android's APIs contains classes and interfaces for Android application development. Great, guys. So hope you understand what is the application framework or Android framework. That is a framework contains Android APIs, and that APIs contains number of different classes and interfaces designed and which is written in Java language. Great. Native libraries are written in the C or C++ language, which is the second type of Android architecture. And in the fourth type, that is the Android framework or application framework, the APIs are designed using Java language itself. Guys, hope you understand what is meant by application framework. So mobile application developers are allowed to make use of these APIs in their applications. Android framework includes following key services. First, Activity Manager. Activity Manager, which controls all aspects of application lifecycle and activity stack by using Activity Manager. That is, it's also one of the API. Content Provider enables applications to access data from other applications or to share their own data. That is, it provides mechanism to exchange data among the apps using content providers. It is also one of the API. Then Resource Manager provides access to non-code embedded resources such as strings, color setting, user interface layout. All these are non-code embedded resources because there is no required of the coding. Color settings, user interface layouts, strings. Great. So these are the resource managers, and for that resource manager there is a API present in the Android framework. Next is a Notification Manager. Allows applications to display alerts and notifications to the user. We know in the nowadays number of applications having Notification Manager service activated, that it gives the notifications to the users instead of sending SMS. Great. So next one is the View System. Contains user interface building block used to build an application's UI including list, grids, text, boxes, buttons, etc. This is all about view system. Guys, hope you understand Android framework and its key services. There are number of other services. Also, we will just overview main services, key services provided by Android framework. Okay, so this is the last type of Android architecture, that is called as applications. On the top of the Android framework, there are applications. All applications such as home, contact, settings, games, browser are using Android framework that uses Android runtimes and libraries. Okay, all these are built-in apps available with our Android mobile phones. Great. Top of the Android application stack is occupied by the system apps and other apps that users can download from Android's official Play Store, also known as Google Play Store. We know number of apps, millions of the apps present on the Google App Play Store. We can download apps from there. Next is a set of core applications are pre-packed in the handset like email, client, SMS program, calendar, maps, browser, contacts, and few more. So application layer uses all the layers below it for proper functioning of these mobile apps. Great. Guys, this is the more important or most important layer because it uses help of the other 4 types of Android frameworks, or there are total 4 layers. So below application there are 3 different layers, and this application layer uses all other 3 layers below it for the proper functioning of the mobile apps. Great. So Android holds layered or grouped functionalities as software stack that makes Android work very fluently in any device. Okay, hope you understand these 4 different types of applications layers in Android architecture. So just we can overview of this different 5 types of Android software stack or Android architecture in short. Okay, so at the bottom there is a Linux kernel. This Linux kernel contains all different device drivers, for example display drivers, camera drivers, Wi-Fi drivers, audio drivers, power management drivers, etc. After that, libraries. Libraries contain OpenGL, SGL, SSL, FreeType, WebKit, libc, SQLite. All these libraries are written in the C or C++ language. Then Android runtime contains core libraries and Dalvik virtual machine, DVM, which is similar to Java virtual machine, which actually run your programming code or app. Then after this layer, this is second layer. After second layer, third layer is the application framework. Application framework contain activity manager, telephony manager, window manager, package manager, resource manager, content providers, location manager, notification manager, and view system. These are the application framework. In this is actually APIs, and these different APIs are developed in Java itself. And last, and the top of the Android architecture, there is an application layer, and these are applications, system level application or other application. All these applications we have developed using Java language, and for this application layer supports application framework, libraries, and Linux kernel and Android runtime. So this is all about Android architecture or Android software stack. Great. I hope you enjoyed watching this video, and if you have any doubts or queries, let me know and write the query in comment box or chat window. So guys, thank you for watching my videos.